All right, let's do section 5.2. This is normal distributions. We're going to be looking at the normal distributions with the data as it comes to us, and then we're going to standardize those into a standard normal distribution using the z-scores. All right, just a little math humor here. Normal distribution on the top and a paranormal distribution on the bottom. Ha ha. All right, so this is what we were talking about in 5.1. You can see on the top here, this graph has the raw data. So under the mean in the middle, the mean is 500, and it shows that to you in the write-up that the mean is 500. The standard deviation is 100. So on the right side, we're going to add 100 each time. So I have 500 plus 100 gives me 600. Right here, plus 100 gives me 700, plus 100 gives me 800. On the other side, we're going to subtract. So we have the mean in the middle, which is 500. We're going to subtract 100 to get 400, subtract 100 to get 300, and finally subtract to get 200. So these are still looking at it as 1, 2, and 3 standard deviations away from the mean, but you've got your raw data on that graph. And then you can see we're shaded to the left of 600. Now, if you come down to this bottom graph, this graph has already adjusted all of the data for with the z-score, excuse me. And so in the middle, we've got a mean of 0. And so if you come over here, if I use my formula for z-score and I put the raw data of 500, right? This middle mean was 500. So if I take 500, subtract the 500, that's the mean, and divide by 100, I get 0. That's what I want. I want that middle mean, or the mean that's in the middle, excuse me, to be 0. Now, if I go one tick mark to the right, there I have 600. So when I want to bring that down to my standardized, then I'm going to use the z-score again. But this time I'm going to take 600 minus my mean of 500 divided by 100. So that gives me a positive 1. And so there I'm going to put a positive 1. And we would keep doing this to go on each side. So on the right-hand side, I have 1, 2, and 3, and that's 1 standard deviation above the mean, 2 above the mean, 3 above the mean. And on the left side, I have -1, -2, -3. The negative tells me that I'm below the mean. And so -1 would be 1 standard deviation below the mean. Okay, so for this problem, it tells me that a national study found that college students with jobs worked an average of 22 hours per week, that's my mean, and a standard deviation of 9 hours. The college student with a job is selected at random. Find the probability that the student works for less than 4 hours. So this 4 hours is going to be my data value. So x is equal to 4. All right, now with StatCrunch, we really only need that much, and we can use StatCrunch. But let's walk through the problem the way they want us to look at standardized. So if we were using a z-table, standard normal table, then we would have to change first using our z-score formula, which is x minus the mean over the standard deviation. If I fill in that data, I would have 4 minus 22 divided by 9. That gives me a -2. Therefore, I want to look at the probability that z is less than -2. And if I use the table or if I use StatCrunch, I would get 0.0228. And therefore, 2.28% of the college students with jobs worked for less than 4 hours per week. Okay, so this problem, we've got the average speed of vehicles traveling on a stretch of highway is 67 miles per hour. So average means the mean. So mu is 67. The standard deviation is 3.5 miles per hour. And then a vehicle is selected at random. So we want to know the probability that it is violating the speed limit of 70 miles per hour. In other words, they're traveling faster than 70 miles per hour. So we have two choices with StatCrunch. We can either go to the normal calculator and just fill in what we know. So we're going to fill in that the mean is 67, the standard deviation is 3.5, and we want x to be greater than or equal to, excuse me, that's my dogs tearing down the stairs. We want, okay, my dogs are getting rambunctious. I apologize. Okay, so we can just put that in. We can put mean, we can put a 67, we can put 3.5 in for the standard deviation, and x greater than or equal to 70. We would get, at that point, the 0.1949. Or if you want to do a little more work, you could actually find the z-score. So we're going to use the z-score formula. We would put 70, which is what was given to us, 70 miles per hour, minus the mean of 67 divided by 3.5. And then we would leave the mean as 0, the standard deviation as 1, because we standardized using the z-table. And then we would put x greater than or equal to 0.86, which is what we found as a z-score. We would get exactly the same answer either way. All right, so let's look at this problem. We've got a survey indicates that for each trip to a supermarket, a shopper spends an average of 43 minutes. So that would be our mean, would be 43, with a standard deviation of 12 minutes. The lengths of time spent in the store are normally distributed and are represented by variable x. So for this first one, we want to know the probability that the shopper will be in the store for between 22 and 52 minutes. So instead of worrying about the z-scores, we're going to go ahead and use StatCrunch calculator normal. So we've got our normal calculator, but this time we're going to put 43 in for the mean. That's from up here. We're going to put 12 in for the standard deviation. That's from right here. And then we're going to go ahead and hit between. At that point, we're going to put the 22 and the 52 in, just like the problem gave us, and hit compute. What's nice is you're going to be able to see that the area is between 22 and 52, and you'll be able to grab your answer, which is 0.7333. At that point, you can round, but that is the area. So that is the probability that equates to the area under the curve for being in the store between 22 minutes and 52 minutes. So on the last slide, I showed you how to do it in StatCrunch. This is how you would do it if you did it by hand. You would have to find the z-statistics, or the z-score, excuse me, for each data point, and then you would have to go ahead and you could use StatCrunch at that point with mean of 0 and standard deviation of 1, or you could go to the tables, which are kind of a pain because you would have to find both of them. So I say stick with StatCrunch. All right, let's set up this problem. Remember, statistics is all about reading. So we've got triglycerides are a type of fat in the bloodstream. The mean level for US adults ages 20 and older is 97 milligrams per deciliter. So here I have mean is 97. And then assume that the triglyceride levels are normally distributed and that the standard deviation is 25 milligrams per deciliter. So they gave me the mean, they gave me the standard deviation. So we want to randomly select a US adult who is at least 20 years old, and then we want to know the probability that that person's triglyceride level is less than 100. So that's what I set up right here. The probability that X is less than or equal to I know that the wording says less than, but in the software, they're going to only let us use the less than or equal to. So in StatCrunch, we're going to go to calculator normal. We're going to put in our mean, going to put in our standard deviation. We're going to put in less than or equal to, and then we're going to put in 100. And StatCrunch is going to spit out the answer for us, which is 0.548 if we round, or if they want the answer in percent, it would be 54.8%. So it's just being really careful reading the problem. The whole part about ages 20 or older, that's just telling you what your population is. That is not part of our calculations because everybody in this study is age 20 or older. Okay, so here's a problem like you'll see in the homework. It says assume a random variable x is normally distributed. We need that or else we can't use the normal calculator. Mean is 86 and standard deviation 4. Find the probability that x is between 76 and 81. So when you go into the normal calculator, you're going to click on between because we want to have those two endpoints. So at that point, we're going to put in the 86 for the mean. We're going to put in 4 for the standard deviation. We're going to put in 76 for the low end and 81 for the high end, and then hit compute. Once you do that, you'll see on your graph that we're just looking at the area between 76 and 81. And then that will give you your answer. Your answer is 0.0994. This one actually wants 4 decimal places. So very straightforward. It's just getting used to where you need to go in StatCrunch. Okay, here's another problem like you'll see from the homework. It says in a recent study of world happiness, participants were asked to evaluate their current lives on a scale of 0 to 10. This is pretty appropriate right now with all of us on a lockdown, where 0 represents the worst possible life and 10 represents the best possible life. So we're assuming a normal distribution. Again, this is important. It tells me that the mean is 4.8 and the standard deviation is 2.6. They have to give it that to you. If they don't give it to you, then and it's normally distributed, then we're going to have a mean of 0 and a standard deviation of 1. So now you're just going to work your way down using StatCrunch one at a time. So the first problem wants you, A wants the probability that a randomly selected study participant's response was less than 4. So that's right here, probability of x less than 4. So we're going to go into StatCrunch. I have it on the next page. We're going to do calculator normal. We'll put in the mean of 4.8, standard deviation 2.6, and then x is less than 4. Hit compute, and you're going to get 0.3792. Then we'll do that for the next. The next one wants between, so we'll hit between and put in the 4 and 6. The mean and standard deviation stay the same. For C, they want to know what the probability that the response was more than 8. So this time, same mean and standard deviation, but we're going to type in that it's greater than 8. And notice that's only about 11% of the participants. Now, at this point, they're going to ask you if any of these are unusual. So for unusual, if we had changed it to a z-score, we could look at it being 2 or more standard deviations away. Since we went ahead and looked at the area, what we want to look at is it will be unusual if the area is less than 0.05. We're used to this 5%, right? In this case, I cannot get this pen to work. None of these are, because the first one is about 38%, the second one's about 30%, and the last one is about 11%. So none of these were unusual. If any of them had been less than 0.05, then they would be unusual. This chart gives you the screenshots from each of those normal calculators for the problem right before. So this is A, B, and C. Notice for every one of them, the mean is 4.8, standard deviation is 2.6. The only thing we change is the inequality and the number we're looking at. Or in the middle, of course, we hit between so that we could put in the 4 and the 6. All right, last slide for this one. So this one, they actually gave us a picture. They said, assume a member is selected at random from a population represented by the graph. Let's see, assume the variable x is normally distributed. So we're going to use the bell curve. So they want us to look at the data being between 200 and 475. So that's what we're going to do here. Again, notice I put less than or equal to. The software makes us do less than or equal to, even though the problem has less than. It's okay. It does not affect the answer in the normal calculator. Now, they kind of hid the mean and standard deviation. It's over here on the side of the graph. So it says that the mean is 513 and standard deviation of 120. So in the StatCrunch calculator normal, we're going to put 513 in for the mean, 120 in for the standard deviation. We're going to hit between, and then we'll put in the 200, 475, hit compute, and we're actually going to get, at that point, 0.3712. And so we're good to go. That is the area here between those two SAT scores. And that's the probability that the next person we look at would have a grade between 200 and 475. So I hope this helps. Go ahead and reach out to me if you have questions.